In this video, we're going to talk about rationalizing denominators. Anytime we have a denominator with a radical in it, it's usually a good idea to rationalize it. It's a little bit easier to work with later on, and so that's one of the reasons why we do it. And we have a little chart here that kind of tells you what to multiply by. So basically, if the denominator contains a square root of 3, you're going to multiply by the square root of 3. If the denominator contains square root of 2, you're multiplying by square root of 2. Notice on the second part right here, if it's square root of 3 plus 1, we're going to multiply by the square root of 3 minus 1, so it changes the sign. And similarly here, if it's square root of 2 minus 3, we're going to multiply by the square root of 2 plus 3. If it's 2 radicals in the denominator, so if we have negative 5 minus square root of 5 minus the square root of 3, we're going to multiply by the square root of 5 plus the square root of 3. And here, this cube root of 4, the reason that you're going to multiply by the cube root of 2 is that the cube root of 4 is 2 squared. So basically, you're missing 1, 2 down there, because what you want to have is the cube root of 2 to the third. And so we're going to multiply by what we are missing, which is the cube root of 2. And when we do that, we'll end up with the cube root of 2 to the third, which is just going to be 2. Basically, we're trying to get rid of the radical, okay? And so we're multiplying by something that will get rid of that radical. Yeah, so basically, we're looking at the denominator. We're determining what do we need to multiply by to get rid of that radical, and then we're going to multiply by that and get rid of the radical, okay? So first off is, why are we able to do that? And that's kind of a big question. Well, remember, if you have a fraction, say a over b, doesn't matter what the heck it is, but as long as I multiply the top and the bottom by the same thing, it's still equivalent. Okay, it's an equivalent fraction, right? We learned that back in the day. So if I have something that's like 1 over the square root of 3, if I multiply the top and the bottom of this by some number, something, as long as I'm multiplying the top and the bottom, it's going to be an equivalent fraction. But since I want to get rid of the square root of 3, I want to end up with the square root of 3 squared down there. And to obtain that, I need to multiply by the square root of 3. But remember, if I multiply the denominator by square root of 3 and I want to end up with an equivalent fraction, I also have to multiply the numerator by square root of 3. Okay, and so what this is going to end up being is the square root of 3. Oh, I don't know why I put a minus there. Sorry for that. The square root of 3 in the numerator, because 1 times the square root of 3 is the square root of 3. And then in the denominator, what we're going to have is the square root of 3 squared, which is going to end up being just 3 if we simplify the radical like we just learned. And so now we have rationalized the denominator. The denominator does not have a radical in it. Let's look at another example. Let's see, we got 5 divided by 4 times the square root of 2. Don't let the 4 confuse you at all. It's still the square root of 2 that we're worried about in the denominator. And so what we're going to do is multiply the numerator by square root of 2 and the denominator by square root of 2. And what we're going to end up with is 5 times the square root of 2 divided by 4 times square root 2 squared, which is going to end up being 5 times the square root of 2 divided by 4 times 2. We can do the arithmetic on 4 times 2, so this is going to be 5 times the square root of 2 divided by 8. And that's going to be our rationalized denominator, our equivalent fraction without a radical in the denominator. It's okay that we have a radical in the numerator. That is fine. And one last example. Let's see, we got 6 over the square root of 2 plus 5. We want to get rid of that square root of 2, but remember, like we saw previously, if it's a root plus a number, we're going to multiply by the root minus that number. So we're going to multiply the top numerator by the square root of 2 minus 5, the denominator by the square root of 2 minus 5. Okay, so this is similar to what we saw with the difference of two squares. Remember that those middle terms cancel out. So we could use FOIL and multiply this whole thing out, or you can see that what's going to happen is you're going to have a square root of 2 times the square root of 2, which is going to yield us just 2, and you're going to have a negative 5 times a positive 5, which is going to yield us a negative 25. The other two times that we multiply when we do this, the square root of 2 times the positive 5 and the square root of 2 times the negative 5, those are going to cancel out. It's going to be a negative 5 square root of 2 and a positive 5 square root of 2, which you're going to end up being 0. So the only thing we're going to have are the first and the last terms. Let's look at the numerator. We got 6 times the square root of 2 and 6 times the negative 5. It's got to distribute to both of those. So we're going to end up with 6 square root of 2, and then 6 times the negative 5 is negative 30. Now we can do the arithmetic down here in the denominator. 2 minus 25, that is going to be, let's rewrite the numerator real quick. That is going to be negative 23. And you could have left this, the numerator factored, honestly. You could have left this as 6 times the square root of 2 minus 5 over negative 23. Because maybe we could have reduced this integer and this integer. In this case, we can't. And so that is going to be our answer. So honestly, either of these is good because what we were trying to do is get rid of the radical in the denominator. All right, that's it for rationalizing a denominator.